So the business school is involved in a new project called REWIRE, and this project is really important to the university but also to the UK economy.
Semiconductors form part of each of our lives, and we often don't know that we're actually using semiconductors.
They are in everything: fridges, electric vehicles, telephones. They are ubiquitous technologies.
I'm leading a UKRI-funded Innovation and Knowledge Centre, which is funded by UK government.
The project that we are doing with our physics department in engineering involves looking at designing and developing the next generation of semiconductors.
REWIRE's aim is to build and commercialize the next generation of power electronics based on ultra-wide bandgap compound semiconductors.
Most electronics and semiconductors, what we find in our daily lives, are silicon. Silicon is something which are called a narrow bandgap semiconductor, and what you surprisingly find if you look at so-called wide and ultra-wide bandgap semiconductors, you have less energy wasted in power electronics in this electronics. We're replacing silicon with new materials. In these new materials, we just have to accept these materials are not as perfect. But despite this contradiction, them not being perfect, you can work with these imperfections and make these devices even better than silicon. And this contradiction always fascinated me, that I can take something which is not perfect and make better electronics. Here's a particular example. This is a converter which uses semiconductors. And if you replace these semiconductors with next generation materials and devices, they perform better, and all this stuff's going to get smaller, so we can build a better, for example, electric vehicle. One particular material system we're looking in Bristol is a material called gallium oxide. It doesn't cost a lot of money to make it, so potentially it could be cheap electronics on the way forward, and that's actually important if many people want to use it. We are the only place in the UK who can actually grow this material and make out of this material good devices, which brings us in a good position actually in the IKC REWIRE to lead the development of gallium oxide electronics. Right now you take a good period of time charging your car, but with things we develop, we hope you can charge your car in 5 or 10 minutes. Wouldn't that be exciting? If you have a car, you plug it in, come back 10 minutes later and you can use it. Why do I need actually a petrol car in this particular case? That's very good for our environment.
This project is truly interdisciplinary. It involves other universities as well, such as Cambridge and Warwick, and we are working very closely with industrial partners like Bosch, Oxford Instruments, Toshiba, and a range of organisations.
There are really exciting jobs out there, people getting trained in semiconductors or supply chain of semiconductors, and great job opportunity. And what I find very exciting is that with this, as a young person, you can actually make a real impact on our environment.
The business school is researching the supply chains that underpin the global semiconductor industry. These supply chains are vulnerable to all sorts of risks, including geopolitical risks, and we will be looking at mapping those risks and strengthening our supply chains.
In the first step, we are going to map the semiconductor supply chain because the productions of the semiconductor materials is highly disaggregated, and there are thousands of production stages across the world. Once we understand the critical spot of the global supply chain, then we're trying to identify what are the risks associated with those different stages. Lastly, in collaborating with the industrial partner, we will co-create the management decisions support toolkit to let the manager understand their supply chain and the risks associated with the semiconductor sectors. The impact of the project and our team's goal is not only to prepare our practitioner to respond to the future supply chain disruptions, but also enhance the government's understanding of the risks and uncertainty in the semiconductor supply chain to support their decision-making in this critical sector.
REWIRE will consolidate UK's position as a leader in terms of generating and commercializing semiconductors.
It has implications for all aspects of our modern life and also national security.
With the technology we develop, we can make the UK to be the leader in green technologies, the leader in actually reducing carbon emissions, and enable the UK be an exemplar for the whole world being an energy-saving nation.